Hello, students. Today we're going to be working on Unit 2, Lesson 6, and it's using equations to solve problems. So this is the warm-up for our class, and in here, I want you to see if you can try to figure out these two questions that are being asked. You can pause the video at this point. All right, so now that you've tried to figure these out, let's kind of take a look at what's happening. I noticed here, so we had a performer selling tickets to a concert and how much money they wanted to make. Don't we all wish we could be a performer making $311,000? But here's what we're going to do. I personally, and you don't have to do it this way, but I like to set up tables to organize my thinking. So like for this one, I'm noticing that we have tickets for T. And in this case, they gave us, they wanted to make, after selling 5,000 tickets, they wanted to make $311,000. So tickets is going to be on my left side, and I'll call this D for dollars. How much they wanted to make. So the first thing says, how much would one ticket be? So I know that would be here on the table because this is tickets. So now I've got to figure out, I'm looking at this and it's reminding me a lot of what we have been doing. So if I had, and here's what I'm going to do, I'm going to show a bar model. So I know they made a total of $311,000, right? And they had to sell individual tickets. So they did that by selling 5,000. So pretend that I have 5,000 boxes. I know that that's a lot. I'm just going to do that to kind of show, because I'm clearly not going to draw 5,000 boxes. So I know that it's 5,000 boxes. So if I have 5,000 of these, I want to find out, well, what's just one of these? So I noticed that this $311,000 is actually being split into 5,000 pieces. So I'm going to go ahead and, use my calculator. And this might be a way that you would do this too on your computers. So I'm going to take 311,000 and I'm going to divide it by 5,000. Let's see. Okay, so I know that for here, that's going to be 62.2. And that's going to tell me what just one of these boxes is. When I look at this, I do know it says, what's the price? And when I look at this, I would never say, I have this much money. This isn't how we would write this as money, right? So I know that money actually goes all the way to this hundredths place in decimals. And I know that if I put a 0 here, that's going to be equal to $62.20. Be careful. I have a lot of students who look at this and would say, oh, that's $62.02. They would do this. But if we look at this decimal with what it really is worth, so the 62.2, if you look at this, this has a 2 in the tenths place and this has a 0. So you can't put a 0 there. We want something equal to this decimal, but just in money, right? And we don't have anything here in the hundredths, which is the same as saying we have 0, right? So just something to think about that I see as a common error. Now, the second question of our warm-up said, okay, how much are they going to make if they sell 7,000 tickets? Okay. So I know I have 7,000 tickets and we actually just figured out. So like each ticket is $62.20. So I know if I want to solve that, I'm actually going to take the price of the tickets for each ticket, one ticket, and multiply it by the number of tickets, right? I have 7,000. So I know my answer is $435,000. $435,400. Okay. So let's take a look. We're going to be doing problems like this today and kind of analyzing them. So let's take a look here. For this, Notice it says we're going to be solving or using equations to solve problems. And our learning targets today, so you can check these off based on what you already know. So we're going to relate all the parts of an equation, like the y, the k, and the x. We're going to know how they relate to a given situation. And we're also going to find the missing information in a proportional relationship using the constant of proportionality, which we actually just did that. So you should be able to check that off if you understood it. We're going to use equations and solve some proportional relationships here. And we're continuing on with our concert ticket scenario. So now I'm looking at what we're given here, and I'm looking to see, it says, okay, it's the same scenario, right? And then it says use the table to answer the questions. And when I look at this, I'm noticing it's the same table that I started, right? We did all of this here. And I'm kind of just reminding myself, okay, we figured out, we did this and we divided it by 5,000, the number of tickets. And that actually showed us that what one ticket is, right? So if you had one ticket, you would know that we multiply this by this to get the price. If we had 5,000 tickets, we still multiply it by the 62.2, right? And we used that same thing to figure out how much 7,000 tickets would cost. So for this question here, it's asking me, it says, if they make $379,420, how many tickets have they sold? And I'm looking, okay, so they've actually put that into my table already, right? So if they made this, how many tickets? So really, we've been doing this for a long time in this unit, right? So the question is, if you have this number, how do you get to here, right? So I know from these, when we take this number and we multiply it by the $62.20, we kind of get the money made, right? In this case, they're kind of telling us this. Here's all the money we made. So they made $379,420. And we know that every ticket is, I'm going to have to write it down here. Every ticket price is $62.20. So really, we're trying to figure out how many, and again, I can't draw all of them, but how many of those tickets could we evenly divide this by, right? So how many boxes would we have? So I know, well, look, if I take that and I divide it by the cost of the ticket, I'm going to be able to see how many tickets there that make up 379,420. So let's try that out. So now I'm going to type it in. And I'm going to divide it by the cost of the ticket. Okay, so I know this is 6,100 tickets. Okay, can you do the same thing? So now instead of this much money, they're making 5 million. So the question is, how could I figure out how many tickets that is? Again, we're going to divide it by the price of one ticket and see how many of those tickets make up $5 million this time. Goodness. So 5, let me make sure, 0, yep, that's 5 million divided by $62.20. Okay, so we got 8, oh boy, I didn't catch that, 80385. And I'm going to write just a couple of these. And we'll say that rounds to about this. Now, okay, so that's true. So it takes, that's 80,385 and 85 hundredths of a ticket. All right, cool. Does that answer the question? How many tickets will they have to sell? Maybe some of you are thinking, wait a second, how do you sell half or not? It's not half. It's how do you sell 85 hundredths of a ticket, a decimal? So it's like a fraction of a whole ticket. You can't, right? If they really wanted to make at least $5 million, wouldn't they have to sell, they'd have to sell 80,386 tickets, right? Because this, you can't sell that much of a ticket, so it kind of has to round up to the nearest ticket. So this is how many tickets they'd actually need to sell. Okay. So let's see what we're going to do. We do have some more with this. So now we have this table, right? And this table is actually showing us all of the things that we've done. All right. So now it's saying, what's the constant of proportionality for this table? Now, I remember that the constant of proportionality ends up, there's a couple ways you can look at it, right? It's the unit ratio, right? It's the unit ratio for this table, which if I look, the unit ratio means if you sold one ticket, how much money? And in this case, it's here. So I know it's $62.20. You might also remember that constant of proportionality is also telling us for this first column, it's saying if we have any number of tickets that we sell, it does not matter how many tickets we sell. If we want to figure out how much money they make, we have to multiply the number of tickets by the COP, or $62.20. So either way, it's $62.20. It also says write an equation. So I'm going to say for this, again, that this is T, and then the earnings is in dollars. So we're going to make that D. Okay. You could technically make these any letters. All right. So when we're asking, if I ask you to write an equation, it's basically saying it doesn't matter. What if you had X? Well, I guess they're making this X instead of T. So let's say we had X number of tickets. This should be X. Sorry. We'll make this Y just to be normal. So if we have X number of tickets, what do we do to every single one of these numbers? No matter what number it is, if we want to get from this number over to how much they made, what are we doing every single time? We're multiplying by $62.20. So we know to get to Y. So Y is equal to the amount of money they earn, or the amount of money they earn is equal to the constant of proportionality, right, which is 62.2, times X, the number of tickets. So for every single one of these, we multiply by 62.2. So X, 62.2X will give us the Y numbers over here. Okay? Now they're asking us, what's the constant of proportionality tell us in this situation? And it seems like a much more difficult question than it really is. Okay? And I gave you a little hint here. I'm basically saying, okay, what does the constant of proportionality tell us about concert tickets and sales, right? So I know, so I'm going to write here, I know that the constant of proportionality tells me that every ticket, costs $62.20. That's it. That's really what it's telling me, right? So in this particular situation, okay? So let's see what we come across next. So we're basically, for this part here, we're going to look at a new situation. And in this situation, we're talking about recycling, okay? And we're going to kind of create some equations and see what they say and what they mean about this particular situation. So here we have aluminum cans can be recycled instead of being thrown in the garbage. The weight of 10 aluminum cans is 16 hundredths of a kilogram. The aluminum in 10 cans that are recycled has a value of 14 cents. So I don't know if you guys have ever done this. We used to do this when I lived at my parents' house. But we would collect all of our aluminum cans, our, Coke and Pepsi and whatever else you might drink out of a can. And then once we kind of had a bunch of them, we would take them to a recycling place and they would weigh them and then they would give us money for the cans, right? And so we're going to use this information. I want you to draw a table that shows this information. So you can do that in your sketch as you follow along. Okay, so some of you might be thinking, gosh, I found a couple tables, and that's totally fine, right? So let's take a look at this. One thing that we could put in a table to organize our thinking, that's really the purpose, okay? To organize our thinking is we know that the weight, and I'm just going to put that as, I'm going to put an arrow here and say, we're going to say that that's W. So we know that the weight of the cans, okay, has a relationship to we're going to call this the number, right? So, and I'll put this out here. So we know I'm going to put the number of cans out here. So N means how many cans we have. The weight is how much they weigh, right? So I know, let's see, 10 cans weighs 16 hundredths of a kilogram. And a lot of times we would put like what the measured is. So this is kilogram, right? Okay. And then I also know, oh gosh, there's something else. So we haven't done this yet. You could have done another table completely, or I'm going to show you how we actually could just extend this table, and we're going to make it, because the 10 cans weighs this much, but then it's also worth, and we're going to call this V for value. So we're measuring that in dollars, right? And it's worth 14 cents. So these are three things that are all related, right? So this shows this information. Like I said, you could have had these in any order, right? It doesn't have to be this particular order. You could have had them in different tables, and that would be fine. So let's kind of take a look here at what we're going to do next. I think that was it for this one. Oh, no, it wasn't. Okay. So the second question on here is, how much would one can weigh, and how much would you get for recycling the one can? Okay, so I'm actually just going to come back up here because it goes with this. So they're basically saying, if I put a 1 here, if we make this 1, how much is it going to weigh? How much is it going to cost? Okay, so I'm thinking, how do I get from here to here? 10 to 16 hundredths, okay? Now, what I know is that, and here's what I'll do. I'm going to put, see, this helps me. You don't have to draw these if you don't want to, but this totally helps me still as a teacher to know what to do. So I know the weight, and I'm going to write this in here, is 16 hundredths. And I know that that's the weight of 10 cans. So I'm actually going to break this into 10 cans. Well, blocks. Okay. Let's see. It's not going to be perfect, but we're going to know that that means each can, it's the same can, or we're going to say that they weigh the same. Each can weighs the same. So we need to know what does one can weigh? All right. When I do this, I then noticed if I want to know what one can is, I literally need to break the 1600ths. Whoops. So 1600ths, 0.16, and I'm going to divide it into 10 equal pieces. So I'm dividing it by 10, and that is going to tell me what one can is, right? So it's 0.016. Oh gosh, which makes sense. I'm dividing by 10. I just move this decimal over one. Okay. But they also want to know how much it costs, right? So I can kind of do the same thing, right? So here's what I'm going to do for this. I know instead of costing 16 cents, it's not 16 cents, but I do know these 10 cans cost 14 cents a piece, or not a piece, for 10. And I'm going to do the same thing, right? Because the total cost is getting divided into 10 equal pieces. So I need to figure out what's one can cost. And so I'm going to divide, even though I kind of already have an idea for the answer, but I'm going to take 14 cents and I'm going to divide it into 10 equal pieces. And I'm going to get 14 thousandths. So that goes over here, 0.014. Okay. So this is telling me how much one can is worth. So, okay, if I'm looking at this in money ways, it's like a little more than a penny, right? Because this is 1 cent and then 4/10 of a cent, if that makes sense. Even though we can't really get paid that much, we are going to use this for when we're calculating later on. Okay, so we have this. Now, we're being asked to, okay. Now we're being asked, write an equation to represent the number of cans C, whoops, I should have made it theirs, and their weight W. Okay, so I'm going to go back up here and I guess I'll change it. This should be a C. At least I had the W, right? So we're going to say that this is cans, okay? So we have to write an equation showing this relationship, right? So, okay, interesting. So I'm looking at this and I'm kind of figuring out something here. When we divided this, that's exactly what we do to find the COP. So I know the COP, so what I multiply the number of cans by is 0.1 or 0.016, right? Because if I multiply 1 by this, I'm going to get this. It's hard to write this in. All right, so since I know that's the COP, I know I can follow this y equals k times x form, right? Remember this? So I'm saying that this is in the y place, right? So we're going to say that this is like the y, even though it's a w, and this is in the same place that our x normally is, even though it's a c. So I know that w, the weight of these cans, so the weight equals 0.016 times the number of cans, C, right? So W was in the Y place, so the weight is where the Y is. The constant of proportionality is what this K means, so I know that it's that. And my X value was the C, right? The number of cans. And now, so this is my equation. Now they're asking us, well, can we relate the number of cans to the value? So can we write an equation to show that, right? So, well, it's kind of the same thing, isn't it? For this one, we're going to make the C be where the X is. the y is going to be like the v, right? So to write an equation for this, we're thinking, well, how do I get the value? The value is going to be equal to whatever I multiplied 10 by to get here. So when I did this, and we got this 0.014, well, that's our COP, right? That's what we multiply 10 by. And it's what we multiply 1 by to get this. So we're going to say, so the value of the cans is equal to the constant of proportionality, right? That number we're always multiplying the number of cans by. Whoops. Times C, the number of cans. So the value is equal to this amount, because that's what 1 can is worth, right? Times the number of cans. Okay. So for this one, we're going to move on, but we're using the same thing. So now we're using this whole thing. If a family threw away 2.4 kilograms of aluminum in a month, how many cans did they throw away? Well, we kind of have to know this information that we had done, which my table's gone, but it'll be helpful for you to have that your table. So what we're going to do is we know that, and I'm going to write the equation that we just did, right? So we know that the number of cans, no, that's not what we knew. Our equation, I'm going to use our equation. So we knew that the weight of the cans was equal to 0.016 times the number of cans, right? We also knew that the value of the cans is equal to 0.014 times the number of cans. So it seems to me, when we're looking at this, we first have to know how many cans is this, right? So we know the number of cans, weight. So we know 1 can is this much in weight. So how do I figure out, what 2.4 kilograms is in number of cans? Remember, we kind of did this in our warm-up. We know that we multiply this number, whatever it is, times 0.016, right? So if we take the weight, we know all the weight is 2.4, right? Then how many cans is that? So if we have, each can is like 0.016, right? So how many boxes is that going to be? We don't know. But if we divide this into how much each can weighs, then we can figure it out. So let's try that. So we know we have 2.4 divided by 0.016. Okay, so that's 150 cans, right? So we know they threw away 150 cans. So see how we use this equation? So this is the weight of the cans, or this is like our y, right? Our constant of proportionality is this. And then C is like our x. It was the number of cans. All right. So let's see what else they want us to find out. What would be the recycled value of those same cans? Okay. So now I think we're going to be using this, right? Because we want to know what's the value. And I'll kind of remind me of my table here. We had the value and the number of cans. We knew 1 can is worth a fraction of a penny, or that's not true. It's worth a penny and then a little bit more, right? And now we're trying to figure out, well, what's 150 cans? So what was it? How did we get from the number of cans to how much it's worth? We know what 1 can is. So if I want to know what 150 cans are worth, I've got to multiply it by that constant proportionality, right? So if I put 150 into this C, I do 150 times 0.014. Let's see. Oh, okay. So I get 2.1. Is that right? Okay. So if I want to answer this, I know, so I put 150 in here, right? So I did 150 times the amount of 1 can, and I got 2.1, but that's not really dollars and cents. So 2.1 is worth, remember, it's not $2.01, which I just wrote. It's $2.10. Okay. All right. So when we're thinking about solving equations, sorry, my dogs just came in and they're a little nuts. Okay. So what were some helpful ways that we organized our information today? Don't know if you recall, but we did a lot of tables. And tables are just good ways to organize information. And also, we used bar models or tape diagrams. That helped us organize some information as well. What were some equations that we found in the lesson? Well, we looked at, and this is a little different than maybe some of them, but we looked at the equation of the value of the cans was equal to 0.014 times the number of cans. That was the last one we had done. Remember way back in the beginning, we had used that Y, the amount of ticket sales was equal to, ticket sales was equal to 6220 times the number of tickets, right? We didn't actually look at this one. So yeah, we didn't look at this one either. So we did look at several different equations. So now I want you to think about, can you relate all parts of an equation like y equals kx to the situation? So for instance, when we said that the weight of the cans was equal to 0.016 C, can you understand that the weight, that this means weight, so the y is kind of like the weight. This is the constant of proportionality, which also means for how much does every can weigh? And this was our x, so this is the number of cans. So can you explain that? If you can check that. Can you find missing information in a proportional relationship using the constant of proportionality? So when we were asking you questions like, how much if a family threw away 2.4 kilograms of cans, how much did they throw away? If you can do that, you're going to hit a checkbox here. So that's it for today's lesson. Thank you.